This presentation is hosted by the Nebraska Energy Office, the University of Nebraska-Lincoln Extension, and National E-Extension, with special funding from the U.S. Department of Energy.
Today's speaker is Barry Scholl from the University of Nebraska. Barry is an architect and works with new building construction and remodels here at the University of Nebraska. And our topic of energy code is a little bit of a change from our kind of renewable biofuel type of topics that we've had quite a bit, but it really is an important topic when it comes to energy efficiency, and is one that will resonate, I think, with all of you through what we see and trying to save energy, and that being one of our low-hanging fruit in today's society. So with that, I'm going to turn it over to Barry.
Thank you, John. This presentation will hardly even scratch the surface of energy codes, or actually building codes in general, more specifically energy codes. There's so much to learn about these, but I just want to give everybody a quick and dirty introduction and let them know what the energy codes are and basically how they'll affect you. And after a quick and dirty history of building codes in general, which I just want to make sure everybody understands codes, I'm hopefully going to shed some light on why everyone should pay attention to energy codes, because they have a significant impact on Americans and where they're most susceptible in their pocketbook. And I believe this quote probably says it the best. A pretty good test of a man's religion is how it affects his pocketbook. The goal of this presentation, again, is to get you thinking about energy codes and how they affect you. And if I can get everyone to understand energy codes, how they benefit homeowners and building owners, I'll feel like I've done a good job. Again, I don't expect anybody to be a code official after this, but just to, again, get a brief understanding that there are these codes and they do actually benefit you rather than hinder most construction. Just a real quick introduction. I am a registered architect, and my title is Facilities Director for the Institute of Agriculture and Natural Resources at the University of Nebraska at Lincoln. I'm not a code official. I do work with codes just about every day, and I'm an advocate of energy conservation. Just again, my education, master's degree in architecture from the University of Nebraska, and I also have a BS in computer science from the University of North Dakota. Someday I can explain how I got from one to the other. I want to give just again a real quick history of building codes, and I don't want to go all the way back to the Big Bang Theory, but energy codes, or excuse me, building codes in general have a very long history. Actually, Mel Brooks did an entire movie, The History of the World, and it was less than 2 hours. I'm going to leave him in the dust and do the history of building codes in less than 10 minutes. So let's fast forward from Big Bang to the Stone Age. Stone Age builders didn't exactly have written building codes. Back then it was more common sense and a simple principle of one stone on top of the other, and this served mankind for millennium. And then actually after a few millenniums, drafty caves, leaky stone roofs, an ingenious young code aficionado discovered a better way. From the picture below, you can see they went from stone to thatch hut. A higher R value, more comfort. It makes me wonder whether this person was an engineer or just a distant relative of Frank Gehry. Coming up to a little bit more contemporary times, relatively speaking anyway, the sixth Babylonian king, Hammurabi, enacted a series of codes for his kingdom, and actually partial copies still exist today. The code consisted of 282 laws with scaled punishment. And the Code of Hammurabi is actually a well-preserved Babylonian law dating back to about 1772 BC. And it's one of the oldest deciphered writings of significant length in the world and written on clay tablets. Makes you wonder how these code officials took this from job to job, but I'm sure Hammurabi made them do it. The Code of Hammurabi, again, consists of 282 laws with scaled punishments, and the term an eye for an eye was actually coined from these laws. And the most applicable to my presentation is law number 229, which states, if a builder builds a house for someone and does not construct it properly, and the house which he builds falls and kills its owner, then that builder shall be put to death. And other than better lawyers, the principle and spirit of building codes haven't really changed much in their attempt to protect the public in the last 5 millennium. Traveling forward in time, the Roman Empire. Rome burned in 64 AD. Narrow streets, tall buildings, combustible building materials, common walls, Commonwealth buildings constructed to the fire's devastation. The fire caused Emperor Nero to create a new urban plan. And actually, contrary to popular belief, Nero didn't just fiddle as Rome burned. He was actually putting his new building codes to music. The changes he came up with were wider streets, restrictions on the heights of buildings, homes that were constructed of fire-resistant materials and stone, such as stone and wooden pillars. Again, you can see things are starting to change. People are starting to notice that, well, if we have a catastrophe, people are going to wonder, why aren't things changing? Even closer to home, both time and space, and on this continent, Chicago. America's fastest growing city in the United States in 1871 was Chicago. Rapid growing population and construction of buildings was mainly wood and other combustible materials. I think I'm starting to see a pattern here. The city had been facing a drought that brought high winds along with it during that summer. In October 9th, 1871, a fire started in the O'Leary barn. Legend states the fire was started by Mrs. O'Leary's cow knocking a lantern over onto the hay. This was never proven, and as far as anyone knows, the cow never confessed. Again, getting back to how do codes evolve? Usually after a major catastrophe. Again, a pattern is starting to evolve here over time. A good majority of code-changing catastrophes in the United States from 1950s to the present have actually occurred since the beginning of 1980. The largest of these catastrophes was Hurricane Andrew, with insured losses of $15.5 billion. After these catastrophic events and a significant amount of public outcry, local politicians usually feel a sudden urge to review their building codes. Again, the first thing to remember about a building code is that a building code is a set of guiding principles that specify the minimum acceptable quality of construction for public safety. A building code doesn't really become a law until a jurisdiction formally is formally enacted by the appropriate authority. So, again, they're just general rules until public authorities actually enact them. Does every state or local jurisdiction write its own set of building codes? There are instances where some local jurisdictions have chosen to write their own building codes. And at some point in time, all major cities in the United States have their own codes. However, due to the increasing complexity and cost of developing and updating building regulations, virtually all municipalities in the United States have chosen to adopt a model code instead of developing their own. It takes a lot of time and effort to keep a building code up to date. Things are constantly changing, and you have to be constantly rewriting the code. A building model code is a building code that is developed and maintained by a standards organization independent of any jurisdiction responsible for enacting the code. One of the most probably recognizable is ASHRAE. This was formed by the American Society of Heating and Refrigeration and Air Conditioning Engineers, and it was really the major building code in the United States. They're still one of the major ones and have a huge force. So I mentioned ASHRAE because it was a group developed by building engineers and really is the Bible for engineers. An example of how engineers think, I'm an architect, but an example of how engineers think, an architect, an artist, and an engineer were discussing whether it was better to spend time with their wife or mistress. The architect said he enjoyed time with his wife. Building a solid foundation for an enduring relationship was what he liked. The artist said he enjoyed time with his mistress because of the passion and mystery. The engineer said, I like both. Both, exclaimed the architect and artist. Yes, said the engineer. If you have a wife and a mistress, they can each assume you're spending time with the other woman so you can go to the lab and get some work done. The moral of this story is architects and artists have passion, engineers have none. Does every state or jurisdiction write their own building code? Again, the majority of building codes used in the United States are developed by the International Code Council, coined the ICC. They actually have a set of 14 international codes, or I-codes, of which the International Energy Conservation Code, or quote-unquote energy codes, are only one of these. To illustrate the point, a quote from a movie, The Pirates of the Caribbean, the Pirates Code are more like guidelines than actual rules. That's the same principle for building codes. The principles set forth by the ICC are really just rough and ready rules that are more like guidelines until a state or local jurisdiction enacts them into law. And codes are not static. They're constantly evolving, new construction methods, new procedures, new mechanical systems, so they have to be really updated continuously. And most states adopt into law the ICC code or use a modified version of them. And the ICC puts out, just for your information, the ICC puts out an update every 3 years. So you'll see the codes as 2000, 2003, 2006, and that's how they're referred to. So, and if you're wondering why building codes, without building codes, this might be your neighbor, and you could be living next to this luxury high-rise. So building codes really do have a lot of benefits. People grumble about them. Builders hate to follow them, but they are really a good principle, and they are in place for a reason, really for public safety, but actually more than that. Now a little bit more about the ICC. It is the major model building code used in the United States. And it has 14 sets of international codes, including the International Building Code, which is really the mainstay of building codes across the U.S. Others include the International Resident Code, International Fire Code, International Energy Conservation Code, International Plumbing Code, Mechanical Code, and others. And really the two newest members of the family are the IECC, the International Energy Code, and the IGCC, the International Green Construction Code. Again, quick and dirty history of the ICC. Since the early 1900s, systems of building regulations in the United States were based on model building codes developed by 3 regional model groups. The codes were developed by Building Official Code Administrators International, BOCA, which were mostly on the East Coast and throughout the Midwest, while the codes from the South and Southeast were Southern Building Code Congress International, and the West Coast was governed by International Conference of Building Codes. These regional codes have been effective and responsive, but were really causing a lot of heartache for builders and building operators. In 1994, the 3 major model building code organizations in the country agreed to merge into a single organization called the ICC. And by 2000, the organizations consolidated all of their building codes into a single code called the International Building Code. Along the way, other code groups got together, the fire code, mechanical, plumbing, and merged into this, so we have really a family of codes and really one code, model code, which is the International Code. This is the beginning of the end of a checkerboard of code jurisdictions that complicated life for many building owners, facility executives, and other building professionals. This is what we've really been waiting for, is a single family of codes. Now that we've slogged through codes in general, what about energy codes? I know you're on the edge of the seat because this is the meat of my presentation. Again, there's going to be a pattern developing here, a crisis, codes, crisis, codes. And the National Energy Codes for Buildings was first adopted in the 1970s. This was largely due to the first energy crisis of that decade. Before the early 1970s, oil was relatively cheap, so constructing buildings that were tight and energy efficient was not very cost effective for builders or property owners. And they had to ask themselves the question, why pay thousands of dollars for building upgrades when it only netted you a few dollars or most a few $100s in energy savings? Really, only a few tree huggers were looking at energy conservation back in the 70s. So it really wasn't a big deal for anybody, architects or engineers, to worry about. However, the era of cheap energy ended in 1973 when an oil embargo imposed by members of the OPEC organization, the Organization of Arab Petroleum Exporting Countries, soon evolved into just Organization of Petroleum Exporting Countries, led to fuel shortages and sky-high prices throughout much of the decade. And quite frankly, they've never come down, and these ramifications have continued for decades. You're going to wonder, how effective were these fledgling energy codes? Engineers took the ASHRAE code, which is ASHRAE 90.75. ASHRAE developed the first model code very seriously. And you'll see a lot of reference in codes to ASHRAE 90.75. 90 was really the first energy code. 75 was the first year it was developed. And again, engineers were very serious. They're real dedicated, and they were using the codes for designing ventilation, air conditioning, and heating systems for buildings. However, many architects like to build glass boxes, which took a lot of heat to cool. Quite frankly, energy codes were largely ignored by architects in the 70s and 80s when designing commercial and residential buildings. Engineers, on the other hand, are more OCD, obsessive-compulsive disordered, and use codes like a Bible. So the moral of the story is, engineers have their feet firmly planted on the ground but have no imagination. Architects have their heads planted in the clouds but have no sense of practicality. And again, I like to think that architects feel about energy codes. Actually, what they did is they stole Bob Marley's motto, don't worry, be happy. Don't worry about energy codes, do whatever you want. But the real question is, who would you rather party with, architects or engineers? A quote by the famous architect Ludwig Mies van der Rohe said, "Architecture is the will of an epic translated into space." A more anonymous quote about engineers: an engineer is someone who is good with figures but does not quite have the personality of an accountant. So the next generation of energy codes really came 2 short decades later. Again, things aren't moving very fast for energy codes. The National Energy Code was more of a guideline throughout the 70s and 80s. After the energy crisis of 73, fuel prices never went down, and the United States was slowly being mortgaged to the Middle East. But the next significant impact on energy codes was the Energy Policy Act, EPAC, of 1992. EPAC set goals, created mandates, and amended utility laws to increase clean energy use and improve overall energy efficiency in the United States. And you're going to see that this was a little bit more saber-rattling than actual meat as far as codes. The EPAC directed the federal government to decrease energy consumption in federal buildings when feasible, and to integrate the use of alternative fuel vehicles in federal and state vehicles. And you can see how well that happened. I don't see any or many state vehicles running around with alternative fuels. I'm sure at the time they thought by the 1990-2000s, every state and federal vehicle would be running on fuel cells. Again, another good idea gone bad. The EPAC authorized tax incentives and marketing strategies for renewable energy technologies in an effort to encourage commercial sales and production. They did establish a comprehensive energy efficiency program that included incentives for energy conservation in buildings and created energy efficient standards for appliances. And I think everybody will know the initials SEER, which stands for Seasonal Energy Efficiency Rating. This is real familiar on air conditioners. And as engineers know, they were like a dog without a bone, and every engineer is like a dog with a engineer with a code is like a dog without a bone. They adhered to these regulations unbelievably well. Architects, on the other hand, not so well. This act is also far-reaching in its impact of energy power deregulation, building codes, and I'll get to that, and new energy-efficient products, which they were fairly good at. This is also the act that was responsible for the mandate of low-flush toilets and outlawing the installation of toilets that flushed more than 1.6 gallons. Some people consider this their crowning achievement, but with energy codes, it's baby steps. Let's fast forward another 17 years to 2009. Between 1973 and 2009, it's not like nothing was happening with energy codes in new buildings. Again, architects took the codes very seriously when designing mechanical systems in buildings. And I know as an architect, they would bring out their code book and beat on architects, we have to follow these procedures. Architects who even knew there was an energy code followed it as long as it didn't interfere with the aesthetics of their building. Many jurisdictions adopted the codes, but enforcement was a mixed bag. Local code officials and inspectors, where there were any, and again, when you get to desolate areas like the far west, Wyoming, and you have code officials few and far between, they had a hard time enforcing even the IBC, the International Building Code, let alone energy codes. Are we starting to get serious, or are we ever going to start to get serious about energy codes? Slowly, the federal government required states to establish minimum commercial building energy codes and consider minimum residential codes based on current voluntary codes. This gave impetus to the creation and modification of ASHRAE 90.1 as a standard model code that provides minimum requirements for energy efficiency design in buildings. And the difference between architect engineers' view on energy codes and an architect's view of energy codes. My glass building faces south. I think I'll submit it for a conservation award. Obsessive compulsive engineers had to take ASHRAE 90.75 and develop ASHRAE 90.1, which again just takes the energy codes and makes them more stringent. Architect's philosophy: if it ain't broke, don't fix it. The bottom line is the federal government was getting serious about codes and enforcement at only a mere 2 decades after energy codes were first adopted. And states are actually starting to adopt these codes. Again, enforcement is less than favorable. But the big question is still, are we finally on our way to energy efficiency? And this picture is really how, I guess, most people perceived energy codes in the 1990s and early 2000s. It doesn't show very well in this picture, but if you look very closely, there are 4 architects in a BMW exiting on the left. Then, a funny thing happened on the way to energy efficiency. Does anyone remember the economic collapse of 2008? Is this going to be another crisis story? I'm afraid so. In order to, again, in 2008, when the economy collapsed, the federal government tried to reduce energy consumption in the United States by providing economic incentives to builders, and they implemented the American Recovery and Reinvestment Act of 2009, ARRA. And this was an interest by the federal government to bring energy code compliance and assessment as they were providing incentives to the economy, to stimulate the economy. This economic stimulus package was pumping billions into the economy for shovel-ready construction projects at federal facilities. And was ARRA a carrot or a stick? In order to receive supplemental state energy program stimulus funding, all 50 states and the District of Columbia pledged in governor's letters of assurance to the Department of Energy not only to meet energy code stringency requirements, but also to create plans and achieve measures up to 90% code compliance within 8 years. States have never before been forced with code compliance. It was all voluntary. Now things are changing. Before 2009, local jurisdictions had the prerogative to develop or adopt codes, but things are getting a little bit tougher for them. Because of this, engineers are happier than pigs in slop. They have even developed computer energy software programs like ResCheck and ComCheck to verify that building plans actually meet the new energy code before they're built. Architects are getting on board, but not without a lot of kicking and screaming. Now they actually have to prove their building meets the new energy code by submitting output from the two software programs to code official before permits will be accepted for a building permit. Architects are starting to wonder, what's this world coming to when you can't take an architect at his word? And after the denial stage, even architects started getting on board. So this is real similar to the 5 stages of grief. Finally, acceptance. Everyone's going green. Energy efficiency is now in vogue. Green buildings, also known as green construction or sustainable buildings, refer to a structure using processes that are environmentally responsible and resource efficient throughout a building's life cycle. And I want to emphasize life cycle here because this is one of the driving forces of the energy codes. We're starting to get people to think about the life cycle of a building. People, homeowners, and building owners are starting to realize that a building being constructed is like a child. It has to be fed with energy for the rest of its life. This is something that really was never an issue to most people. It was, how inexpensively can I get this built? Now they're starting to think about how I'm going to be able to feed this beast for the rest of its life. The common objective is that green buildings are designed to reduce the overall impact of building and of the building environment on human health in the natural environment. Efficiently use water, energy, and other resources. We're trying to protect human health and improve employee productivity and reduce waste and pollution. So we're going actually far beyond just building an efficient building that's tight and doesn't waste energy. We're worrying about the environment, health, and the production of waste and pollution. Again, we have some energy codes. They're starting to actually be accepted by people. And people are starting to think, these aren't so bad. Now, everybody's jumping on the bus. LEED, the Leadership in Energy Efficiency and Design, is an organization. It's the U.S. Green Building Council, USGBC, is a nonprofit trade organization that promotes sustainability in how buildings are designed, built, and operated. USGBC is best known for the development of the Leadership in Energy Efficiency and Design, or Green Building Rating System. LEED is redefining the way people think about the places where they live and work. As an internationally recognized mark of excellence, LEED provides building owners and operators with a framework for identifying and implementing practical and measurable green building design, note measurable, construction, operation, maintenance, and solutions. Instead of using common sense in design and construction of buildings, the LEED organization actually gives architects and designers silver, gold, and platinum stars on the building for meeting certain criteria of building energy efficiency and sustainability. But they also charge a fee for doing the paperwork to make sure we are meeting their requirements. Very least, it's making people aware of energy efficiency, and if this is what it takes to get architects to design an energy efficient building, then kudos to LEED. I personally think it's extortion, but it's working, so I'm keeping my comments to myself. Next was Energy Star. Energy Star is a joint program between the U.S. Environmental Protection Agency and the U.S. Department of Energy. It's helping us all save energy and protect the environment to energy-efficient products and practices. In 1992, the EPA introduced Energy Star as a voluntary labeling program designed to identify and promote energy-efficient products to reduce greenhouse gas emissions. It's, again, an international standard for energy-efficient consumer products. National programs to recognize homes that are 30% more efficient than standard construction. This is their big foothold into energy codes, because they actually have their own rating system, and they have people that go out and measure homes. It's not just a matter of taking anybody's word. They actually have to have metrics to prove a home is more efficient. And finally, they developed energy performance rating systems for several commercial and industrial type institutional buildings and manufacturing facilities. The green bus is leaving the station and is starting to fill up. In 2012, the International Green Construction Code is going to be coming, or they're writing it now, and it's called the 2012. So you're going to be seeing a lot of this in the future. The IGCC, again, International Green Construction Code, is the first model code that introduces sustainability measures for the entire construction project and its site. Again, not just the building, the construction process, and the site. From design to construction, and a certificate of occupancy and beyond. So really, we're taking it from inception of a building all the way through the life cycle of a building. This new code is expected to make buildings more efficient, reduce waste, and have a positive impact on health, safety, and community welfare. IGCC creates a regulatory framework for new and existing buildings, establishing minimum green requirements for buildings and complementing voluntary rating systems, which may extend beyond customizable baseline of the IGCC. Future energy codes will start to dictate, again, that we have more efficiency than existing building codes. As you can see, Energy Star said we want a 30% reduction. Future building codes are going to dictate these even more. The buildings are going to become more and more efficient in the future. The benefits of energy codes. Again, I'm hoping that I can show people that there's actually a benefit to these codes and that it affects everybody, and hopefully, I guess, where it's going to hurt them most in their pocketbook. But the other benefits are reducing the environmental impact of construction and I guess, just operating buildings in general. It's an awareness of life cycle assessment of buildings. Energy efficiency in commercial and residential buildings. Building codes are helping indoor environmental quality enhancement. They're helping with material efficiency. Building codes are helping with the operation and maintenance optimization of buildings. More specifically, saving homeowners and building owners money as these buildings get old and they need energy to operate for the rest of their lives. Energy codes help reduce waste reduction. And I guess a biggie and hopefully a big future benefit is energy codes will reduce the dependence on foreign oil. Again, they're protect the environment, save natural resources, and help homeowners and building owners. Buildings have a long life and will continue to be heated and cooled for a long time. So these energy codes being enacted now and how buildings are built now will really have a long-term impact. In conclusion, and I know everybody's probably cheering by now after hearing me, and I'm not the best public speaker, but it's been a long road, and we are finally on a path to constructing energy-efficient buildings. You can see by the pictures here, from stone houses to glass houses to finally energy-efficient homes. How do we make sure builders and designers are on the same page by trying to do the right thing? Energy codes. Again, it's not only designers, builders, homeowners, everybody will and should know about energy codes. They should realize they're out there. There's a lot to energy codes. There's lots of details. Homeowners should be knowing, as their builders building a building, they should be checking their building just to make doubly sure things are getting done. code enforcement will hopefully be picking up with energy codes as it does with building codes. So, wanted to thank you for putting up with my ramblings. There's always more to learn about codes. Again, I haven't even scratched the surface. I just want to make everybody aware that there are codes, and they need to understand that they are a benefit to them. Thank you very much.
This presentation has been brought to you by the Nebraska Energy Office, the University of Nebraska Lincoln Extension, and E-Extension.